Okay, so today during class we had some technical difficulties and the camera kind of kept cutting out. So I'm going to go ahead and go over the notes that we took today and kind of discuss what we were talking about. So today our lesson was titled How Many Atoms Are in a Penny? We had a little bit of reading to do within the lesson, and we discussed the Greek philosophers Aristotle and Democritus. Aristotle was the forerunning thinker of the time. Democritus disagreed with Aristotle. Democritus said that everything could be cut down, and then there would be one point where you couldn't cut it in half anymore, and that one thing that you were left with was an atomos. And he named them atomos. Well, Aristotle didn't agree with him, and people agreed with Aristotle, so his idea was kind of lost until the 1800s, when we have John Dalton, who kind of picks up the idea again, and he said that the atom was a sphere, a ball, a hard ball, and there was just a bunch of them all put together to make different kinds of matter. J.J. Thomson came up with the idea of the chocolate chip cookie model. So it's kind of the ball with dots on the outside, and he found the electron. We're going to go into these guys a lot more in depth later on, so this is just like a preview of them. Ernest Rutherford found the positive nucleus, so the model changed from a ball to a teeny little ball and electrons flying around the outside. Then part of the reading starts to talk about a penny. So you want to think about a penny. There are 20 hexillion atoms in a penny. I mean, check this out. It's got 22 zeros. It's a lot of zeros. So I pose the question, could we count to 20 hexillion the number of atoms in a penny? And so we did a little bit of math. And the fastest counter in our class could count to 42 in 10 seconds. So if we multiply that by 6, we're going to get 252 in a minute. So the fastest counter in our class could count to 252 in a minute. So with some unit analysis, 252 per minute, there's 60 minutes in an hour, 24 hours in a day, 7 days a week, and 52 weeks in a year. And if we did that for 100 years, we're going to come up with this number here. So not even close to the number of atoms in a penny. Then we got a little crazy. I mean, what about 7 billion people? So all the people on all the planet, old people, young people, all the people that can't count for whatever reason, all the people on the planet counting for 100 years would only get to the 92 pentillion, all this. So the idea is that if that many atoms are in a penny, we could never, ever count to the number of atoms in a penny if we count for 100 years, every person on the planet, night and day, no going to the bathroom, no eating, just counting. So the bottom line, atoms are insanely small. I apologize for having to redo the video, but hopefully if you need to, you can pause through the notes and kind of think about it. But this math right here is pretty intense. For 100 years, all the people on the planet could never count to the number of atoms in a measly little penny that you or I might not even pick up if we found it on the street. So atoms are insanely small, and promise we'll get better at this, making videos. Have a great day.